Good evening, ladies and gentlemen. The webinar today will be organized by the Sri Lanka Association for the Advancement of Science, Section E1, and the Physics Society of University of Sri Jayawardhanapura with the collaboration of Sri Lankan Atomic Energy Board. I warmly welcome our guest speaker, Ms. Uththara Perera, the Scientific Officer at the Atomic Energy Board, and I also welcome all the members of the Sri Lankan Association for the Advancement of Science, Section E1, and all the lecturers of the Department of Physics and all the undergraduate to the webinar today. The topic of the webinar will be the general overview of the Sri Lankan Atomic Energy Board. Without further ado, I would like to call upon Dr. Vasanthi De Silva, the President of the Sri Lankan Association for the Advancement of Science, Section E1, to introduce the speaker today. Madam.
Yes, thank you, Varishi. First, I would like to thank Ms. Uththara Perera. So she's accepting our invitation very kindly and did kind of a necessary arrangement to have this webinar. So we are trying to collaborate with the Atomic Energy Board in future activities as well. So I would like to introduce our guest speaker today, the Miss Uththara, obtained her BSc Honours degree in Botany at the University of Rupuna. Also, she completed her MSc in Nuclear Science at the University of Colombo. She was a Fellow of World Nuclear University 2019. Currently, she is a Scientific Officer attached to the Industrial Application Division of Sri Lanka Atomic Energy Board. They're currently working as the National Project Coordinator of the Program of Nuclear Science and Technology, Education for Schools, and in the field of isotope ecology. Previously worked in the International Cooperation Division of SLAEB, which is the National Liaison Office to International Atomic Energy Agency. So, I would like to invite Ms. Uththara to deliver her speech today. That will be very informative and very useful to our students, so that the students not only limited to the University of Sri Jayawardhanapura, that will give more knowledge to the other university students as well. So over to you, to Ms. Uththara.
Thank you, Dr. Vasanthi. Can you hear me clearly and see my presentation?
Yes, everything is fine.
Okay. Okay. You all are welcome to my presentation on Sri Lanka Atomic Energy Board. Sri Lanka Atomic Energy Board is looking for sustainable development of nation through nuclear science and technology. We are functioning under the Ministry of Energy, and our we are functioning under the Ministry of Energy. Under that Ministry of Energy, there's a state ministry called Solar Power, Wind, Hydropower Generation Project Development Ministry. So we are functioning under that state ministry. Sri Lanka Atomic Energy Board is the governmental organization which promote peaceful application of nuclear science and technology in Sri Lanka. It establishes necessary infrastructure and maintain facilities in the country by obtaining international cooperation. Sri Lanka Atomic Energy Board, or SLAEB, provides a wide variety of services to the nation using that technology. And as well as one of the responsibility of our organization is to protect general public, environment, and the radiation workers from ionizing radiation. We are responsible to engage in activities involving ionizing radiation and complementary techniques as well as. Let's see what are the complementary, what are the ionizing radiation and complementary techniques. Before start the presentation, I add 2 slides to brush up your knowledge, refresh your knowledge on radiation. Everyone knows about the electromagnetic spectrum. At the end of the electromagnetic spectrum, at the high energy side, there are X-ray and gamma ray. So X-ray and gamma ray are ionizing rays. Other than those ionizing rays, there are ionizing particles that make ionization. Those are alpha, beta, and neutron. Sri Lanka Atomic Energy Board, from our act, we are responsible for the work related to these ionizing radiation. Other than the ionizing radiation, we are responsible to work on complementary techniques as well as. Let's see what are the complementary techniques. You all know about isotopes. Isotopes have same atomic number and different neutrons in the nucleus. There are two kinds of isotopes, stable isotopes and unstable isotopes. Unstable isotopes always prefer to be stable. Therefore, they emit radiation. There are two kinds of unstable isotopes. One type is naturally occurring radioactive isotopes. Other one is man-made radioactive isotopes. So, other part is stable isotopes. Stable isotopes are cycling in the environment like other elements. So, using this stable isotope, we can find out natural fingerprints of ecological systems. Knowledge of the stable isotope composition help us in many ways for environmental studies, food and agriculture, industry, so on. Next, before coming into the organization work, it is important to know about the organizational timeline. Our mother organization, current name of the organization is Sri Lanka Atomic Energy Board. Our mother organization was Sri Lanka Atomic Energy Authority. That was established in 1969, according to the Act number 16 of 1969. Later on, in 2002, we got our own building on Orgodawatta Vellampitiya. I had milestone of our organization history here. And in 2014, there are two institutions developed, Sri Lanka Gamma Center and National Center for Non-Destructive Testing. In 2014, we developed new act, which is called Sri Lanka Atomic Energy Act number 2014. According to this new act, Sri Lanka Atomic Energy Board divided into Atomic Energy Authority divided into two institutions, Sri Lanka Atomic Energy Board and Sri Lanka Atomic Energy Regulatory Council. Sri Lanka Atomic Energy Regulatory Council is responsible for the regulatory work regarding nuclear science and technology. Sri Lanka Atomic Energy Board is the organization that I'm representing. Our main mission is to be center of excellence for activities related to peaceful application of nuclear science and technology. As I mentioned earlier, we have two centers and the head office. The head office located in Orgodawatta Vellampitiya. One center, which is Sri Lanka Gamma Center, we call SLGC, is located in Biyagama Export Zone. And the other center, National Center for Non-Destructive Testing, is located in Kelaniya. And this is this slide shows the staff of the SLAEB. We have nearly 185. We have 185 cadre positions. Nearly 160 is filled now. 57 represent male and 43% represent female workers. Nearly 48% of employees are graduates. Let's see what vision and mission of the Sri Lanka Atomic Energy Board. Vision is sustainable development of nation through nuclear science and technology. And mission is to promote and encourage peaceful application of nuclear technology while ensuring safety, security, and quality, as well as provide radiation protection service. let's see what are the objectives of Sri Lanka Atomic Energy Board. Staff of Sri Lanka Atomic Energy Board is committed to high standards of professionalism, safety, security, and ethical behavior in peaceful use of nuclear technologies for the benefit of the nation. These are the objectives. We have 5 main objectives from our Act. These are the objectives we have to work on. First one is, as I mentioned earlier, promote and encourage peaceful application of nuclear science and technology. I have mentioned here the word peaceful application because we have ratified the Treaty of Non-Proliferation of Nuclear Weapons. So we are highlighting the word of peaceful application every time. Second one is conduct research R&D work on nuclear science and technology and provide services using these R&D findings. Third one is promote, support, innovation and ensure safety and security systems and quality in the peaceful use of nuclear technology. Fourth one is provide radiation protection services to meet regulatory requirement relating to nuclear applications. Last one is, I earlier mentioned that we have 2 industrial centers providing industrial opportunities for the nation using nuclear science and technology, ionizing radiation and using ionizing radiation and complementary techniques. Sri Lanka Atomic Energy Board's in this slide, I put sustainable development goals here. Sri Lanka Atomic Energy Board itself contribute for 10 sustainable development goals. Those are, we directly contribute to zero hunger and clean water and sanitation, good health and well-being, affordable clean energy, industry innovation and infrastructure, climate action, life below water, life on land, and partnership for goals. You know, there are 17 sustainable development goals. From that 17 sustainable development goal, we are contributing for 10 SDGs. These are the divisions of Sri Lanka Atomic Energy Board. We have 9 divisions. There in green color, you can see 3 scientific divisions located in our head office: Life Sciences Division, Industrial Application Division, Radiation Protection and Technical Services Division. In purple color, there are, I show the 2 industrial centers: Sri Lanka Gamma Center and National Center for Non-Destructive Testing. In yellow color, you can see the supportive divisions, which are finance, HR, and internal audit. Other than those divisions, there are international cooperation division. This division mainly works with the international organizations in order to obtain technical assistance. Let's come into our first division, Radiation Protection and Technical Services Division. This division provides quality service to protect general public, environment and radiation workers from radiation. Also, they provide radiation protection service to meet regulatory requirements, as well as they are technical service providers to ensure safety, security and nuclear technology applications in the country. These are the subsections of this division: personnel monitoring and occupational exposure control service, secondary standard dosimetry calibration, nuclear instrumentation, emergency preparedness, radiation monitoring, nuclear security, radioactive waste management, information service, and promotional and library service. Let's go through one by one. Personnel monitoring and occupational exposure control. Objective of this service to protect radiation workers from ionizing radiation. We have island-wide external dosimetry service. We provide this service using thermoluminescent dosimeters. We call it TLD readers. This personal monitoring and occupational exposure control service is to control the occupational exposure of the radiation worker. How to do that? Radiation worker has to wear this TLD reader on their overall during their performing their work. This badge can record the radiation level the worker get exposed. Every 2 months of time, this dosimeter should hand over to our PMS laboratory. It means Personal Monitoring Services Lab for reading. This lab issues certificates for the each radiation worker. This certificate has the history of their radiation exposure. Also, this lab maintains those records and issues certificate when it necessary. Secondary standard dosimetry calibration service. This service maintains secondary standard gamma beam and medical standard X-ray beam. They are provide island-wide calibration services for radiation measurement and diagnostic radiology machines in compliance with ISO standards. I mentioned that they maintain secondary standard gamma beam. They are calibrated according to the primary standards from IAEA. Source of gamma beams are cesium-137 and cobalt-60. They calibrate personal dosimeter, air monitors, survey meters, contamination monitors. They provide service for irradiation facilities, nuclear medicine unit, and non-destructive testing facilities. Next section of that division, nuclear instrumentation service division. Service section. They design, develop and fabricate new radiation detection instruments, systems and method. Also, they provide repair and maintenance service for radiation measuring and other related equipments. Next part is emergency preparedness. Sri Lanka Atomic Energy Board maintains emergency preparedness system. You know, Sri Lanka is non-power country, which means we don't have any energy generating nuclear reactors or research reactors. But in our neighboring country, they use nuclear energy. They have a lot of nuclear power plants. Close nuclear power plants in India to Sri Lanka is Kudamkulam and Kalpakkam. If some accident happen there, in nuclear power plants in our neighboring country, there should be a system to monitor that. So, emergency preparedness system is maintained and monitoring of the nuclear disaster early warning. So, you can see in this map, there are locations in green color. Those are detector stations which has installed now. We have to install 3 more detectors in these locations which are showing in red color. These are GM counters, and these detectors maintaining the nuclear disaster early warning system of the country to identify the possible transboundary nuclear disaster that could affect the country. Also developing the technical capabilities on collecting baseline data, radiological assessment, decontamination, dose management, and radiation protection for responding to radiological nuclear accidents, disasters to ensure the safety of the people and the environment. Next part is radiation monitoring service. They provide service for radiation measurement of peoples, objects and test samples. This includes the method development for radiological assessment, advancement techniques, development and maintaining the detection systems used for radiation measuring. This section is related to nuclear security. This figure shows an illustration of the relationship between the material under regulatory control and material out of regulatory control. Here it shows the material under regulatory control, and this side it shows what happened when material coming out of the regulatory control. If the material become out of the regulatory control, there are three things to do: prevention, detection and response. Here I mention the word material. In here, nuclear security subject. We call material for nuclear or radioactive material. We call the material here is for nuclear or radioactive material. These exist in variety of forms and uses. As an example, cesium-137, cobalt-60, those are nuclear materials. There are prevention measures that are implemented to provide deterrence against loss of regulatory control out of the material. Measures include legal framework governing nuclear and other radioactive material, information security trustworthiness check on personnel, and the visible or public advertising of capabilities for detection and responses. If material leaves regulatory control for any reason, including accident or theft, additional measures are required for locating the material. If necessary, we have to mitigate the consequences of contamination and exposure too. Detection measures are implemented to locate material out of regulatory control. These measures can include the use of radiation detection instrument, but may also include non-technical detection capabilities like law enforcement and operational information. Finally, response. Response measures are necessary if material out of regulatory control is released into nuclear security event, resulting in radioactive contamination or exposure to human beings and the surrounding environment. Response measures serve to mitigate the consequences of nuclear security event. This is how the nuclear security is going on. Radioactive waste management. We have radioactive waste management storage near to our head office. Development and maintenance of this division develop and maintain the central disused sealed radioactive source storage. Sri Lanka, we don't usually radioactive waste categorized into three: high level, medium level and low level. In Sri Lanka, we don't have high or medium level radioactive waste. We have only low level radioactive waste. We can store them near surface repository in a waste treatment facility. This division also provide information technology service as well as promotional and library service related to nuclear science and technology. Let's come into our second scientific division, Life Sciences division. Life Sciences, I have put here the logos of SDG, some logos of SDG. That means this division contribute for these SDGs directly. This division responsible for providing efficient and effective nuclear analytical testing service for regulatory requirements, as well as they are doing R&D work in the field of life sciences application and food and agriculture. There are 5 nuclear analytical facilities. Life Sciences Division maintains 5 nuclear analytical facilities. gamma spectroscopy, X-ray fluorescence spectrometry, inductive coupled plasma mass spectrometry, ICP-MS, gross alpha beta counting lab, isotope ratio mass spectrometry, IRMS. Let's go through one by one. Gamma spectrometry laboratory. This method is used to determination of radionuclide in a large variety of food and environmental samples. Potassium 40, radioactive isotopes like potassium 40, lead 210, radium 226, thorium 232, uranium 235. Those are natural, we can found in our environment naturally. In environment as well as food items, we can found these radioactive isotopes. So here we measure the gamma photons emitted from radioactive nuclide in the sample. The gamma measurement can be made directly on the samples without any sample processing. This division have HPG detectors as well as sodium iodide scintillation detectors. Gamma spectrometry laboratory is the highest income earning laboratory by providing analytical service because Sri Lanka is milk powder importing country. So when importing milk powder, Health Ministry has imposed the regulation to measure the radioactive level of the milk powder. So this gamma spectrometry laboratory provide radioactive certificate for the Health Ministry to distribute milk powder in the country. So cesium, we check here cesium-137 and cesium-134 activity level should be below the 20 becquerel per kilogram. This is the level of the milk food other than milk powder. This cesium-137 and cesium-134 level activity level should be lower than 100 becquerel per kilogram for the food other than milk powder. Other than the milk and food products, they test imported organic fertilizer for radioactive measurement. Other than those analytical services, they are provide R&D services by measuring norms, naturally occurring radioactive materials in fly ash, building material, mineral sand, as well as they measure cesium-137 level for soil erosion and monitoring studies. Also, they are providing lead-210 levels in soil or sediment, which can be used as dating tool. Next analytical laboratory is X-ray fluorescence spectrometry lab. We have both here. In this laboratory, we have both benchtop facility and portable facility. Here we hit the sample by primary X-ray. Primary X-ray come from the X-ray tube of the instrument, and each element of sample get excited and they emit secondary X-ray. Since the electronic energy level of elements in the sample are different, energy of X-ray fluorescent peak can be correlated to specific element. X-ray XRF analysis applications are measurement of heavy metals in soil, sediment, plants, aerosols, and minerals. Also, they provide qualitative analysis of raw material. Gem quality and they can identify gem quality and non-gem quality. Also, identification of elements in stones and ornament. Third lab is gross alpha beta counting laboratory. Radioactive materials usually dissolve in wastewater and drinking water due to natural causes and man-made activities. So, dissolved radioactive materials can be measured by using this gross alpha beta counting laboratory. Analytical service for gross alpha beta measurement for wastewater is carried out under the regulatory requirement of the Central Environmental Authority. Gross alpha beta counting laboratory has been registered under the CEA as a consultant for environmental pollution control and management. To release the wastewater or waste effluent to the environment, the radioactive material limit should be less than this amount. Alpha emitter should be less than microcurie 10 to the power minus 9 per milliliter. Likewise, CEA impose this regulation in the wastewater effluent discharging industries has to follow this guideline before discharge the effluent to environment. Other two laboratories are isotope ratio mass spectrometry, inductive coupled plasma mass spectrometry. Isotope ratio mass spectrometry, these two labs have developed recently. ICP-MS technique is facilitating to measure multi-elemental concentration in parts per billion level in different sample types such as water, soil, sediment and plant material. The other recently developed lab, which is first ever IRMS lab in Sri Lanka, this analytical service open for students as well as customers. They provide trace element heavy metal analysis in drinking water, soil and plants. Other than those laboratories, other than those work carried out by those laboratories, there are ongoing R&D projects under that Life Sciences Division. They have these ongoing R&D project. One is enhancing food safety and supporting regional authentication of foodstuff through implementation of nuclear techniques. Enhancing wetland management and sustainable conservation planning. Development of organic food authentication technique and determination of fruit juice adulteration using stable isotopes. Assessing and improving soil and water quality to minimize land degradation. Development of rapid screening method to assess authenticity, safety and quality of important and local produced milk powder. Uses of stable isotope and multiple element analysis as a traceability system in authenticating cow milk of Sri Lanka. Strengthening national capability for food and food safety. Assessing the impact of urban air particulate matter on air quality. Those are the R&D projects carried out by Life Sciences Division. Next division is Industrial Application Division. Under the Industrial Application Division, nuclear, isotope and related technologies applied in the field of environment, industry, health and agriculture in the country. Industrial Application Division OIAD also provides related consultancies and analytical service for stakeholder institution and other respective research institution and organizations. Addressing national needs in the above field is in priority research areas of IAD. These are the subsections of that division: isotope hydrology section, radiation processing, and isotope ecology. Isotope hydrology section provides technical assistance to the water sector institution, organizations and researchers for groundwater management and water pollution assessment. In addition to that, Technical support is provided by the Isotope Hydrology Division to the Dam Owner Institute for leakage and seepage investigation in dams, tunnels and reservoirs. Investigation on groundwater origin, groundwater recharge, surface water groundwater mixing interaction, groundwater flow dynamics, seawater intrusion, surface water and groundwater pollution, so on, to fulfill the national needs in water management and protection. Leakage, seepage investigation of dams and reservoirs. In this context, this division has laser mass spectrometry and liquid scintillation spectrometry, ion chromatography. Laser mass spectrometry used for water isotope analysis, oxygen 18 and deuterium analysis. Liquid scintillation spectrometry used for tritium and carbon 14 analysis. Ion chromatography used for major ion analysis in water. Other than those three instruments I mentioned, they use conventional method for water quality testing. They are providing research-based information and data for national and international institutions. Global network isotope in precipitation is a global network. This division, this isotope hydrology section, responsible for provide data for that global network of isotope in precipitation, as well as they are responsible for provide data for global network of isotope in rivers. The other section under the Industrial Application Division is Radiation Processing Section. It conducts research to develop new products or to perform value addition to the existing products using ionizing radiation for the purpose of quality enhancement, protection, conservation, productivity increase in industry, health, agriculture and archaeology. Under the above scope, following research programs were conducted in the recent past. They have developed plant growth promoter for agriculture sector. Also, they have developed super water absorbent. It is also for agriculture sector. It is used for dry area cultivation and hydrogel-based wound dressing. They are doing value addition of gems by enhancing their optical properties. Also, they are developing radiation grafted oil absorbent material for water treatment. They have another research activity that they develop radiation treatment methods and new resin formulations for consolidation and preservation of achieved material and cultural heritage artifacts. Other section is isotope ecology. Stable isotopes frequently used as tracers in biological system and environment due to their ability to track changes and process over time has made them increasingly important to ecological research. Isotope ecology use isotope tracers in correct and creative ways to solve environmental problems. Under the isotope ecology unit, maintain a smart greenhouse system. Currently, one research project is going on under this ecology unit. The title of the research is Increase of Productivity under Drought Conditions by Using Stable Isotope Techniques to Optimize Water Usage. This project aims to contribute improving crop productivity plants under water limiting conditions using nuclear, isotopic and related techniques. I have mentioned earlier that we have two industrial centers. One is National Center for Non-Destructive Testing. Prime objective of this center is to provide training, certification, inspection service on non-destructive testing and related techniques as per international standards. Non-destructive testing is a process of physical inspection process. Here material, they're doing physical inspection of material without causing any damage or harmful consequences to the material. It is widely used technique in the industry to inspect the quality of the production and as well as part of routine inspection and maintenance in services. They use 5 techniques: eddy current testing, magnetic particle testing, liquid penetrant testing, radiographic testing, and ultrasonic testing for non-destructive testing services. National Center for Non-Destructive Testing is launching its activities mainly in directions of training, inspection, welder qualification, R&D, and national certification body to achieve its objectives. Training unit in the NCNDT, they have training unit. This training unit conduct non-destructive testing training courses and workshops. These courses and workshops are in line with the ISO standards and internationals. They following international standards and guidelines as well as. Objective of the training unit is to qualify personnel, qualify NDT personnel, and control quality, increase quality assurance, quality control of inspectors, technicians, welders, engineers, and surveyors in the industrial field, such as metal fabrication, aerospace, oil refinery, petrochemical, shipbuilding, repair, and many other construction and manufacturing industries. NDT inspection services. NDT provide island-wide inspection services for power plants, boilers, aircraft, ships, bridges by using above techniques, and they also doing concrete testing for building inspection. Certification of NDT personnel. Mission of certification of NDT personnel or CBNDT is to establish and facilitate NDT personnel qualification and qualification activities in Sri Lanka to create value for the field of NDT. Welder qualification facility. NDT have NCNDT have welder qualification facility. They have established fully equipped welder qualification facility recently. This facility used to provide certification for welders, supervisors, and inspectors. Those are skilled enough to compete in the international job market. The certification system is compatible with the international accepted schemes such as CWI, CS, WIP, so on. The other industrial center is Sri Lanka Gamma Center. Gamma Center started in 2014 in the Biagam Export Zone. This is the only government-owned multi-purpose gamma irradiation facility. This gamma facility is continuous carrier type 1, and the initial activity of the gamma source is 250 kilocurie. There's a gamma source is cobalt-60 source. This facility is 24-hour operating with a dedicated operational staff to utilize its maximum benefit. Let's see what are the services provided by Sri Lanka Gamma Center. They provide irradiation service to industries, entrepreneurs, researchers. They provide their services in compliance with ISO standards. They irradiate disposable medical products, surgical products, cellulose products, pharmaceuticals, and laboratory supplies, cosmetic and sanitary products, biological materials, and other than that, they do decontamination of spices, seasoning, dried vegetables, medicinal herbs, Ayurvedic products, health diet supplements. Also, they give quarantine treatment service for agricultural product, wooden object, coir and coir based product, provision of R&D service. They provide R&D service for universities and institutions. They have maintained microbiology testing service here. And this Gamma Center has two conveyors. One conveyor is commercial and the other one is auxiliary conveyor. Commercial conveyor has mainly dedicated for customers. Auxiliary conveyor dedicated for R&D purposes for universities, research institute. Those are the divisions and centers of Sri Lanka Atomic Energy Board and their activities. Other than the divisions, we have some ongoing projects, important ongoing projects. I will give you some brief information on those ongoing projects. One very important project is establishment of cyclotron-based PET radiopharmaceutical production facility. This project directly contributes for SDG 3, good health and well-being. Everybody know that cancer is one of the major health burden in Sri Lanka. It's growing day by day. So the aim of this project is to produce radiopharmaceutical, FDG radiopharmaceutical. This FDG need for PET scanners. Currently, we are importing this SDG from India, and 90% of the SDG importing SDG is decayed during transporting from India. So if we can success this project, we can provide PET scanning for patient for low cost. That is the objective of the this ongoing project. And second one is geological approach to verification of origin of Ceylon tea. This project is contributing second SDG, which is zero hunger. Aim of this pilot project is to demonstrate the chemical fingerprinting technique can differentiate Ceylon tea from other origin tea using stable isotope and trace element analysis and record the chemical fingerprint that will develop or select regions within the country. Third major ongoing project is nuclear power study and planning program for electricity generation. Aim of this project to provide strong technical, environmental, financial and social understanding for policymakers to take firm decision on nuclear power development in Sri Lanka. And the next one is education and awareness raising program on nuclear science and technology. This project is targeting school students as well as we have planned to approach university students too. Production of nuclear instruments for practical experiment and demonstration. We have in SLAEB We have instrumentation laboratory. Instrumentation lab has developed a kit, radiation measuring instrument kit. That kit consists of gamma meter and GM counter and cloud chamber. We are providing these for schools for the practical experiments. Last ongoing project is establishment of multi-purpose facility. Other than those in divisions and projects, we have very important division in our organization, which is International Cooperation Division. This division works as National Liaison Office to the International Atomic Energy Agency. This division provides facilitation for acquired technical cooperation, technical assistance for the feasible application of nuclear science and technology. This division coordinates with international organizations such as IAEA, International Atomic Energy Agency, NEXT, which is from Japan, JICA, and RCA, HOICA, Rosatom, Russia, like institute. Universities in USA, this division cooperate with those institutes. And IAEA, this is the image of International Atomic Energy Agency. International Atomic Energy Agency provide, this information might be important for you all. They provide international internship program. They are providing internship program for graduates. You can go through this URL and find out whether whether there is suitable internship program that can apply by you. Other than that, IAEA provide fellowship program, Marie Curie fellowship program, that is especially for women. You can also try these two links. Opportunities for university community from Sri Lanka Atomic Energy Board. We provide industrial training. We conduct undergraduate. You can conduct your undergraduate research here, and you can do sample analysis with special discount, and you can have facility visit here. Develop international projects in collaboration with scientific staff. Obtain international technical cooperation through IAEA. Scientific visit, fellowship, training, meeting, workshop. You can get the equipment support also. IAEA International Nuclear Science Technology Academy. International Atomic Energy Agency is going to launch INSTA from 2022. University community can get benefit from this INSTA too. Also, if you wish to join Sri Lanka Atomic Energy Board, you can start your career as a scientific officer. This is our contact details, and thank you for your attention.
As a secretary of the Physics Society of University of Sri Jawaharlal, and on behalf of the Physics Society, I would like and take this opportunity to thank our honorable guest speaker, Mrs. Uththara Perera, for taking her time from her busy schedule for a valuable lecture today. Through this webinar, we gathered more knowledge and a general overview of the Sri Lankan Atomic Energy Board. Thank you, Madam, for this valuable information you provided, and looking forward for a session in the future. Next, I would like to thank Sri Lankan Association for the Advancement of Science Section E1 for collaborating with the Physics Society to organize the webinar today. Finally, I would like to thank all the students and other participants who gathered today to grace the event. We believe you learned a lot today through the webinar, and thank you. So this concludes the session today, and we believe you learned a lot. Till then, thank you and stay safe.